Okay, for today, okay, so the problem had a C here, and we have a 32 here, and we have an 8 here, and a 9 here. And just so we can all have the same letters, I put a B here and an A here, but we all know that A and B could be reversed. Okay, now, is this a law of sines or a law of cosines question? Well, you don't have an angle and the side across from it, so it's obviously a law of cosines. So then you'd set up 9 squared plus 8 squared plus, nope, minus 2 times 9 times 8 times cosine of 32. And this is the easiest kind because it's just all one big equation and it equals c squared. All you got to do is take a square root at the end. Compare with the kid next to you and see what you got. Okay, so it comes up to 22.8. You take the square root of that and you get 4.78. If you want to round to 10th place, it'd be 4.8. And yay, we figured out this side. Now, how do we take that? If I'll stick with 4.78 for now. How do I take that and find an angle? I personally would use the law of sines now, because now I have a side and the angle across from it. When you do law of sines, I personally would start with the variable. I want to know angle A. So I'd go sine of big A. Why do I want to put that on top? Because it's so much easier to solve for. Over 8 equals sine of 32. Might as well use the other combo where it's got the side and the angle across, 4.78. And in the end, I'm going to multiply and then do inverse sine. And what did you get for A? Let's get random person. Row 2, first person likes you.
62.49.
And I'm going to round that to 62.5 degrees. Raise your hand if you had 62.5 degrees, or at least rounded close. Okay, good. Then, last but not least, I'd use 180 minus the other two angles to get that last one. 180 minus 62.5 and minus another 32, and you should have gotten 85.5. Final answer for that final angle. 85.5. Okay, any questions about law of cosines and the law of sines? Because they're going to come up, but that's not it. Okay, then here's one more kind of question we should practice. What if I have all three sides? Let's say this is 8, and this is 9, and this is 10. Would you please find two things? I would like to know the biggest angle and then once you have the biggest angle, figure out, I would not use that new formula I just gave you yesterday. I'd use 1/2 A, B, and what's the rest of that formula? Sine C to find the area. So find the angle first, biggest angle. Now, in the real world, totally fine to use that semi-perimeter way. But in this case, because I want you to find the angle first, then I think it's actually easier to do this. Pausing. Okay, Robbie, tell me a setup. How'd you do it?
I did a squared plus b squared. So,
Yep, I know. And then let's put in the numbers.
64 plus 81 minus 2 times 8 times 9. Cosine C equals 100.
Now, a lot of people mess these up because they're not careful with this next part. And I know we could just jump right to the answer, but I really don't want to because I got to show people how you do this. It's not everybody. Frankly, most of you, probably 59%, already did this right. But it would be 145 here minus 16 times 9, 144 there. Cosine of big C equals 100. Robbie, what's next?
You subtract 145.
You are correct. And now I got negative 144 cosine of big C equals negative 45. Divide both sides by what?
Negative 144.
And I have negative 45 divided by negative 144, and I get 0.3125. Raise your hand if that sounds familiar. Awesome. Final answer then. Row 4. Last person, Mr. Mack.
Just the answer?
Yep.
71.8.
71.8. Can anybody verify the 71.8? Okay, awesome. All right, and once you know this angle is 71.8, and I got to figure out, you said this all with the 8 and the 9, you know, as your A and the B. That means you were figuring out this one. And so, Robbie, did you call out a certain letter?
C.
Yes, that was a good call. All right, so if that's angle C, and it's 71.8 degrees, then when you find this formula, you probably use that same thing. 1/2 times 8 times 9 times sine of 71.8. Robbie, what'd you get for a final answer for the area?
It was like 36. I didn't write it down.
Okay, how about if I get somebody else to tell me, because they probably have it written down. Row 3, person 3. That's you.
34.2.
Raise your hand if you had 34.2. Okay, good. I feel like you guys are good on all that. You've got, what if I give you all three sides? What if I give you a law of sines? What if I give you a law of cosines? And so what's left? What's the one kind of problem we haven't talked about? What? A little louder.
Right triangles, maybe?
We haven't done right triangles, true. And there's one other thing, but I'll do right triangles first. Yes, the ambiguous case question. But for right now, we'll do a right triangle. This is a right triangle. And I would like you to simply figure out if this is 9 and this is 24 degrees, how long is this? And don't use the law of sines. If you are using the law of sines, you fundamentally don't understand trig. I get law of sines is a cool thing, but you need to know how to use SOHCAHTOA. We're going to be using it left and right and sideways and upside down. So you've got to be able to find sine of 24 and know what that is. You got to be able to find cosine of 24 and know what that is. And you got to be able to find tangent of 24 and know what that is. And not just the decimals, but the fractions, like, you know, what over what. Now this last side, I do think it's better to pick a letter like A, B, or C, but if you called it H, that would make some sense. It's the height of the triangle. I get H can also be hypotenuse though, so that could have been confusing. You could have said it was X. I don't care. I'm going to use X this time just to show I'm not fixed on A, B, and C. It doesn't have to be that. So sine is X over the hypotenuse, which I don't know. Do you get how that one's not going to be very useful? Okay, so I'm not using that one. Cosine is adjacent over hypotenuse, 9 over the hypotenuse. And that would be great if I wanted the hypotenuse. Okay, so this would solve, but it would solve for H. But I don't want H. I want X. So tangent is TOA, which is opposite over adjacent, which is X over 9. That's my ticket right there. Do you understand what I mean by that? Okay. So this is 9 tangent and 24. 9 times tangent 24 is 4.000. So pretty much it's 4. Raise your hand if you had that one right. Okay, awesome. Now let's do the indeterminate case thing. So imagine you've got an angle. Usually we call this angle A. And to me, if the way I drew that one, it looks like it's about 40 degrees. And let's say this side is 10. Now, you remember how this works where this last side could be like that and that, or it could be straight up and down. And have I given you enough info to finish this problem? No, I haven't given you only 2 things. You always have to have 3. So, what you are going to figure out is if this is B1 and this is B2, let's say I am your boss and I'm trying to build this ramp thing, and I say, you know what? I want that last side to be 3. And you suspect that, hey, boss, I don't think that's going to connect. The way you would prove that I'm wrong is figure out the height. And some of you are like, but there isn't a triangle, so there isn't a height. No, there's a height. This red line, that's the height from here to here. Whether or not there's a side there, that's still called the height. Everybody figure out what the height is. And then you got to be able to tell me with proof. Either, yeah, that'll work, boss, or no. Sorry, boss, that's not going to work. You guys are going to probably come out of college and have a boss. Sometimes they're going to ask you to do things that aren't possible. All right, so first up, you should have said sine of 40 equals that height over the hypotenuse. Sine is opposite over hypotenuse, right? So 10 sine of 40. 10 sine 40, and I get 6.42. So you'd be saying to me, boss, you can't. The smallest it can be is 6.42 or 6.43. All right, so what if I say, okay, fine. Let's make it 7. Then you'd have to say, that could be 2 different triangles, right? So let's do that. Now that I'm saying it's 7, would you please figure out what angle B1 and angle B2 would be? Just to clarify, B1 is this one, and B2 is this red one. I'll pause for a second while I try that. If the first one here turns out to 66.7, just for the people at home, in case there's a kid who's like, I don't get how you got that. Can you tell me the setup for that, Jack?
Yep, I did love sines of sine 40 over 7.
Sine 40 over the side across from that is 7. Keep going.
Equals sine b over 10.
All right, awesome. And then you solved and then you did inverse sine and you got 66.7.
Yep.
And then what else is 66.7?
It's the other angle to the left of that.
Yeah, that one over there is also 66.7. And then last but not least, what's this one?
113.3.
All right. So then, answer this question for me. That side could have been bigger than 7, couldn't it? It would have been ambiguous until it hit what? Until it hit 10. At the second it hits 10, now there's only how many triangles you could make? As soon as it hits 10, there's only 1 triangle you could make. If it's 10, it would have to swing out that way because then it would be an isosceles triangle. There'd be only 1 triangle you could make. What if it goes to 11? Nope, not possible. Some people think that. Goes to 11, it's still possible, isn't it? You just have to go further this way. And so sides that are bigger than 10 are fine. You just won't get any ambiguous cases out of that. Okay, cool. I think you guys get the main stuff that you need to get. At this point, don't start the Schoology quiz because I'm about to change one last question on it. The last thing I want to make sure you get is the 30, 60, 90s, those classic right triangles. There's a 30, 60, 90. And a 45, 45, 90 triangle. Do you know the side ratios on those? If you do, you should be able to answer this question. Put the classic one here. The sides that you can always use on the 30, 60, 90. Here and here, this is the 45, 45, 90. And then if this side here is the square root of 11, figure out this side. Okay, I'm gonna pause for a sec. We give that a try. Okay, let's see how I would have done it. First of all, you do need to know these ratios. I'm telling you, it's gonna come up in circle trig like 1,000 times. So 1, 2, and the square root of 3. Raise your hand if you remembered that side ratio thing. Okay, good. And I suggested that on a problem like this, that you could call this x, and always start with the variable, and you go x over 1 is to what? Do you remember this deal? This is to this, like square root of 11 is to square root of 3. And if you think there's a faster way, I don't think so. I mean, that's pretty fast. Now, I know, could have used like law signs, could have done all of different kinds of things. Let's find that, but that's pretty quick. All right, so how about the 45, 45, 90? Do you guys know those numbers? Random person. Row 4, person 1, that's you, sir. What's the ratios on this?
1, 1 squared.
1, 1, square root of 2, nice. So what if I make a side that's just like this side is 7, it's just too easy. I want you to contemplate that for a moment. What are the other sides? 7, and then what's this last side? 7 square root of 2. Okay, so if I give you one of those sides, I never would because it's just too easy. But I might, because this really messes with people, put a square root of 3 right here. And I wouldn't have given you these numbers, the 1, 1, root 2, like, because you're supposed to memorize them. And then people get confused because they're like, oh, the square root of 3, isn't that the 30, 60, 90 triangle? And then get all messed up. I want you to solve this one and figure out how long these sides are. These right there. I think this is our last question. So here's what I would have done. I would have said this is 1, 1, and root 2. I would have said, I want to know one of my sides. I don't care which one. Just pick one because they're the same. And then I go, x is to, always start with the variable. X is to 1, like root 3 is to root 2. And if this was multiple choice, and we did that to it, why in the heck would we do that to it? Square root of 6 over square root of 4, which is 2. Do you get this could have been one of the multiple choice answers? Think that through for a minute. Did you have root 3 over root 2? Okay, good. Or if you had a decimal for that, that's fine. But what is this thing? That's me multiplying by 1 in a creative way that clears the denominator. It's called rationalizing the denominator. Some classes spend tons of time on that's like you can never have a square root in the denominator. And I get it. The reason we don't is because that in AP Calc, the AP Calc test does not require you to rationalize denominators. But I have seen it on the ACT before where they clear the denominator like this by multiplying by the square root. So just so you know, you could see that. All right, I have one last one. Thought of something else. This time you have to draw it. Angle C is 140. So I'd start by just drawing a 140-degree angle, and then I'd call that angle C. Side A is 6. Side B is 9. What is side C? Little c. Just to clarify, that's a little c. I guess I should say side. And let's make it to the tenths. Tenths place. And last, what is angle A? Also the tenths. Sometimes people really struggle with how to draw it. But I think by now, I think you're better. We'll find out. All right, here's what it actually looks like. 140 is pretty big. Maybe even bigger than that. But you don't have to be super accurate when you draw it. That's C. Then I'm going to connect them so that I can have side C. Side C we don't know, so I'm putting a little C here. Side A is 6. Now, if I'm looking at these two sides, the way I drew it, that looks like 6, and this looks like 9. So I'm going to choose them to be those letters, because A and B can be on either side, right? So A is 6, and B is 9. Now, you might be like, but I drew mine different. It won't matter, as long as you made the short side of your triangle 6, and the long side of that other side around the 140 has to be 9. All right. Now, is this law of sines? Nope, don't have enough info. Got to be law of cosines. Jacob, have you finished with letter C yet?
Yeah.
And what did you get?
I got 14.1.
14.1. Can anybody verify 14.1? All right, excellent. And then angle A. I'm guessing you probably used law of sines for that. I'll take a volunteer that hasn't talked yet today. Appreciate people chiming in. Yes. 15.9. Can anybody verify the 15.9? Okay, awesome. Now, pro tip, save this problem because one of your Schoology quiz questions is this exact question. All right, so there's a Schoology quiz I'm going to launch in just a second. I wouldn't start it yet if I were you, because it has 2 more questions to add on at the end that I'm about to hit like save. So, and then there's another quiz that's more like a paper kind of a quiz. I just attached the key right to it, so it's all in one document. That's the one I think you should do right now. There's a PDF. Start that one. There's an answer key for it, and then tonight, do the Schoology quiz. It'll be one last chance to practice, and I feel like you will rock this test tomorrow. All right, that's all I got for the video for today.